In this video, we are going to go through some of the Java exercises. So let's start with section A. The first question is, what is the code used at the end of a line of code? For sure, that will be C, the semicolon. Remember, for example, if we do system.out.println hello world, there's a line of code, we always end with a semicolon. Question 2, in Boolean operation, if not M, remember the exclamations mark here is not. If not M is false, then which of the following applies? The answer is D, if M is true and false otherwise, because we have the exclamations mark here, which is the not operator. So not M is false. It says here, if not M is false, which means that M is actually true. Okay, that's why we have the answer if M is true and false otherwise. So for the third questions, which keyword used to select more than one options? The answer, or the most accurate answer, is actually B, if. In this case, the questions ask that keywords used to select more than one options. So we're looking at the conditional statements here, which means we need to use if. The fourth question is, within a loop in Java, you need to code your program so that it will execute the conditions later. What can be used to accomplish this? So for sure that will be do while, because for do while loop, we will do first, then only we will check on the conditions. Questions 5. What is stored in X in the following line of Java code? We have integer X, Y, and Z. X is equal to 0, Y is equal to 1, but then I do X is equal to Y is equal to Z is equal to 8. So in this case, my X will become 8, right? So the answer will be 8. Let's run this. So I get 8. Why is it so? Because even though I assign initial values of 0 to X, but later on in this line of code, I actually change or update the value of X to 8. That's why my X will be 8 now. Question number 6, evaluate the following Java expressions if X is equal to 3, Y is equal to 5, and Z is equal to 10. The answer is 25. Let's run this first before I go through it with you one by one. So definitely the answer is 25 here. Remember, this is about the increments and also the prefix and postfix, which we have learned in another video, right? So you have prefix here, plus, and you have postfix here. Okay, so let's go through it one by one. We have plus Z here. Plus Z is actually prefix, which means we are going to add 1 first before we do the calculation. So that will be, now my Z will be 11. And then I have a Y, which is 5, that's fine. Minus Y is still 5, my Y here. So I indicate here Y is equal to 5. Y is equal to 5. Then I have plus Z. So I have another Z here. Because my Z is already after the increment, so my Z will be remain as 11. And I have X plus plus. X plus plus here indicates this is postfix, right? So postfix, I will use the original value for calculation. So my X will still be 3. Sorry, this should be X. Now, if I do the calculations here, 11 plus 5 minus 5 plus 11 plus 3. So plus 5 minus 5, I can remove that. 11 plus 3, that will be 22 plus 3, 25. Question number 7, what is the output of the following switch statement? So here I have a switch statement checking on the character. And if you run this, you will get B, which is equal to A. Now let's run this and verify the answer. So if I run this, I will get A, because if my character is A here and it matches the case of A, okay, I will print A. Okay, because I have a break keywords here, which we should have for each of the cases, then it acts normally. the programs acts as intended. But now let's say if I remove this, what will be the output? If I remove the break here, you will see 2A, right? Let's run this. You'll see 2A here. Why is so? Because you have A here, it matched the case, it print A, and then because we do not have the break keywords, it's overflow to the second statements here. That's why it will print the character once again. We see AA, then only you have the break keywords. Okay, so that's important for us to have the break keyword in each of the cases. Section B, determine whether the following variables are valid or invalid. If invalid, state why. So the first one, we are going to run it one by one. Integer Ronaldo 7 is equal to 1. So if I run this, I will get an error because we know that there's a white space, right, between Ronaldo and 7. So this is not a valid variable. So if I remove that white space and I run it, I will get 1. So the variable is correct. The second one, integer if equal to 1. If I run it, then I will get a, let's run it. So it's correct. Well, some of you might mistaken that, why is it so? Because this is actually a keyword, right? Because if else. But the problem here is for this if, the I is actually capital letter. So if the I is capital letter, it's not the same as the if that where we use all this while, the IF with the I small letter. So this is actually a valid variable, right? Now, the third one, and sum. Okay. You run it. And sum here, this is actually invalid. Why? Because I have the and sign, which is not allowed when I want to name a variable. So and sign here is not allowed. I'm going to put a note here. If here, this is valid because the I is capital letter. I'm going to write the answer. This is invalid. And this is invalid. The first one is invalid. Now let's move on to the third one. Integer 1 Malaysia with the 1 as a number here. Of course, this is invalid because I cannot start a variable with a number. So we get invalid here. Whereas if I, let's say, put the 1 at the end, this will become a valid variable. Okay, this is a valid variable. So I'll put a note here. This is invalid because we cannot start with a number. Right. Now, finally, we have US, and then there's a $sign there. Let's run it to see whether this is valid or invalid. This is actually valid, right? I can have a $sign. There's no problem with that, but you need to use it carefully. Usually we won't include $signs when we're naming variables because it has a different meanings in Java. It's valid, but it's not recommended for you to use it. Let's move on to question 2. Suppose x, y, and z are floating point variables that have been assigned values x equal to 4.8, y equal to 2.0, and z equal to minus 3.2. Determine the value of each of the following arithmetic expressions. So to test it, we have defined 3 variables here, x, y, and z with the value, and I'm going to go through this with you one by one. So the first one is 2 multiply y, okay, plus 3 multiply x minus z. So 2 multiply y is 2.0, so I get 4 here. Okay. I get 4 here. And plus 3 multiply, there's a bracket in between here, 4.8 minus 3.2. If 4.8 minus 3.2, that will be equal to 4.8 plus 3.2, right? 4.8 plus 3.2, okay? So 4 plus 3 multiply 4.8 plus 3.2. So that will be equal to 4 plus 3 multiply 4.8 plus 3.2. That will be equal to 78. So there will be 8 here. So that should be 24. So 4 plus 24. My answer should be 28. So let's run this. Run only one of these. I have to system without our print line here. Sorry again. So 28. So the first one is 28. Now let's move on to the second one here. Y divided by 2 plus 2 minus z. So I need to do y divided by 2 first. Y is 2. 2 divided by 2, that will be equal to 1. Plus 2 minus z. I have 2 here. Minus z, I know that z is minus 3.2. So in this case, 1 plus 2, that will be equal to 3. 3 minus minus will become plus, so plus 3.2. My answer should be 6.2. Okay, let's run it to verify. I get 6.2. Now the third one, 2 multiply x divided by 3 multiply y. 2 multiply x is 4.8 here, divided by 3 and then multiply 2.0, which is y here. 2 multiply 4.8 will be equal to 9.6. 9.6 divided by 2 multiply 2.0. 9.6 divided by 2, that will be 3.2. Multiply 2 here, so I should get 6.4. Okay, let's run it. 6.4. Yes, 6.4. Now, x modulus y, and then you have plus plus. So plus plus here is actually postfix, right? Postfix, because it's not in front of the variables. X is 4.8 modulus 2.0 y plus plus. So 4.8 modulus 2.0, that will be equal to 0.8. Then I assign that value to variables. Then only I do the plus plus, because plus plus, remember here, this is postfix. So my answer should be 0.8. If I run it, I'll get 0.8. That's correct. So you can see here you have, up to 1, 2, 3, 4, 5, 6, 7 decimal points. But if you provide the answers 0.8, that will be counted as correct. Finally, x divided y plus 3 multiply z. So x is 4.8 divided by 2.0. We'll just straight away do the calculations. That will be 2.4, right? Plus 3 multiply minus 3.2. 3.2 multiply 3, that will be 9.6. Okay, so minus 9.6 here. So here, 2.4 minus 9.6, I should get minus 7.2. Okay, should be correct. Now, if I remove this and I run this, I get 7.2 here, minus 7.2. Okay, so you just need to remember how to do the evaluations. You need to do the multiplications first, then only divisions, and then plus minus. Third one, write a pseudocode that can convert the number of days into years, months, and days by assuming 1 year equal to 365 days and on month equal to 30 days, right? So for example, if the numbers in days is 400, then the output will be 400 days is equal to 1 year's 1 month. So, well, to be exact, this is 1 year without the S, 1 month and 5 days. Okay, so basically, through the pseudocode, you need to show that you actually understand the problems and you can propose an approach to solve the problems. And if we look into this, then we know that we will actually need to use modulus to solve these problems. So I've written a pseudocode here, a straightforward one, which you can easily convert that into a Java programs, where, as I said earlier, you always need to start with the keyword start. And then you need to define the input. So for example, here, because it says the numbers in days is 400, so my input will be total days equal to 400. You can even declare variables here. And I define my days in years and also day in months based on the information provided in the questions, which we assume that 1 year is 365 days and 1 month is 30 days. And then I move on to show the processes here, where I need to calculate the number of years, I use divide, and then I find the modulus here. And then I move on with number of months, and then I use modulus to find the remaining days. Then I output the years, the months, and the remaining days. Well, as I said, the most important thing is you can show that through the pseudocodes, you know how to solve the problems. And in this case, the specific keywords will be you need to use modulus to find the remaining days. And later on, when you're writing the Java programs, then you will need to kind of like specify the data type. So in this case, for example, this one, you will need to use integer so that you can get a whole number. Based on that, then only you do the modulus. Question number 4, rewrite the following code segment as an equivalent segment that uses a for statements. Before we do this, let's run the original code to kind of like understand what is happening in this while loop. So it will ask the user to input a number here. For example, I try 10 here, okay? Then I will get j is equal to 2, j is equal to 4, j is equal to 8, and then I have 9 here, okay? So I input 10. When I input 10 here, while my I is greater or equal to the number, which in this case will be, well, my 12 is greater or equal to 10, right? Then I will do the looping. So for the first loop here, I'll have my j, which is equal to 1. Remember these multiplications equal symbol here. When I do j multiply equal to, this is actually equal to, j is equal to j multiply 2. Okay. So in my first loop, my j will be equal to 1 multiply 2. That will be equal to 2. Now let's go to the second loop. Remember, before I go to the second loop, I will have this I minus minus. So which means that now my I here will be reduced to 11 from 12, right? So in the second loop here, my I is actually 11, okay? Whereas for my j will be equal to j multiply 2. Remember my j, the final value of my j is 2 here. So that will be 2 multiply 2, then it will be 4. Okay. I go to the third loop. Of course, I'll need to minus my I for 1. So that will be 10. Now, when my I is 10, j is still equal to j multiply 2, but now my j is already 4. So 4 multiplied 2, that will be equal to 8. Okay, and then I reduce my I by 1. Now my I is equal to 9. Okay, so the question is whether 9 is greater or equal than my number. So 9 greater equal my number. What's my number? My number which I have input is actually 10. So 9 is equal or greater to 10. So this is false. That's why I come out from the loop. And you can see here, finally, I print the final value of my I, which is 9 here. Okay, which is 9 here. I've come out from the loop, so I'm not in the loop when my I is 9, but I still print here. You can see here, I print it here. System not print line I, so my I will be 9. You'll see j equal to 2, j equal to 4, j equal to 8, and then system dot print line I is 9. So how I'm going to convert that into a for loop? Well, what I will do is I will first copy this because this should be the same here. Okay. And then I will start to do a for loop here. So for the for loop, I will need to look back into this. So what I'll do is I'll just copy this one. Okay. And I'm going to paste it here. I'm just remove it. Okay. Put that as a comment just for reference purpose. Okay. Now for, okay, integer I. Okay. So my I is 12, right? So I initialize it as 12. But I do not need to actually have that integer because I already initialized that integer I. So I remove the integer here. Okay. As long as the I, okay, is greater or equal than the number. So if you notice the conditions here, I move it into this here. Remember, this is initializations, conditions, and then I should have the update. So what is my update? My update is I minus minus. So I'm going to put this into my for loop here. And then I'm going to open and close brace. Then I'm going to copy everything here into my for loop. And because this one is actually outside of the loop, so this should be here. Okay. So remember, for the for loop, you have the initializations, you have the conditions, and you have the update. Okay. So if I run this, I should have the exact same output as the while loop, given that if my input is 10. Okay, so you can see here, j is equal to 1, 1, 1. Okay, that's an issue here. So what I'm missing here is, well, I missed one of it, which is the j multiply equal to 2, right? Okay, so I need to have that. I'm going to put that here. J multiply equal to 2. Okay, let's run it again with the same input 10. Now I get 2, 4, 8, and then I have a 9 here. So I have the exact same output as the while loop. So we will work up until these sections for this video. And in the next video, we're going to look into section C. Thank you very much.